I thought that this was an appropriate quote. Friction. A little trip down memory lane here. Today's class is brought to you by the letter mu and the number 1. Honestly, who doesn't like Big Bird, right? Okay. All right. So, word of the day. You may be able to figure this out, but we'll sound it out. Frick. Shun. Frick. Shun. Frick. Shun. Frick. Shun. Friction! Yes, the word of the day is friction. What is friction? It's a force that exists between two surfaces which are in contact. Friction resists motion. So if you have a box moving to the right, sliding across the floor, the friction must be pointed to the left. What causes frictional forces? Well, two boxes or two surfaces that are in contact may appear to be relatively smooth to us, but if you look at them microscopically, you will discover that there are actually little peaks and valleys and dips and divots, and the two surfaces have a tendency to interlock together. This is what causes friction. The smoother the surfaces, generally, the better you're going to be able to move an object. Now, we can't have friction without an equation. So here is the equation for friction. Notice we have a force of friction and we have a force normal. So it would appear that the force of friction is equal to the normal force. But there is a nice little letter that's in there. That is our Greek symbol mu. And it stands for the coefficient of friction. A coefficient just means a number. So we have force of friction equal to mu times force normal. Force normal, remember, is the force of a surface pressing up against another surface. Usually, not always, but usually the force normal is equal to the force of gravity pulling the object down. So the force of friction is generally going to be some factor of the object's own force of gravity. Something you have to know about mu. It's always greater than 0, and it's always going to be less than or equal to 1. So think about this. If mu is 0, then the force of friction would be 0. You'd have a frictionless surface. But go to the other way. If mu is equal to 1, then the force of friction is equal to the force normal. You can never have a force of friction that is greater than the force normal. The force of friction will always be less than or equal to the normal force, the force of the surface pressing up against another surface. So here we have an example. A 2.6 kilogram box has a constant velocity. We want to find the coefficient of friction mu. We have our formulas. Delta F, or sigma F, remember this stands for sum, or net force, is equal to mass times acceleration, and force of friction is equal to mu times the force normal. So we draw the free body diagram for our box. We have a normal force, we have the force of gravity, and these are balanced out. We have an applied force of 6.5 newtons. We'll assume that the problem told us that. And there's a friction force. What is the friction force equal to? Let's think about that for a second. If the box is moving with a constant velocity, remember the most important question for us to ask ourselves is the box speeding up, slowing down, or is it staying the same speed? Well, in this case, it's staying the same speed. So all the forces must be balanced. Therefore, the force of friction must be equal to 6.5 newtons. Mathematically, it would look like this. We would start with Newton's second law, F equals ma. All the forces acting in the horizontal direction are the applied force and the force of friction. And these two forces, there's a subtraction sign here because they're working against each other. And these forces cause the mass to accelerate. However, there's no acceleration. So it's force applied minus force of friction equals 0. If I add force of friction to both sides, I get an equation that looks like force applied equals force of friction. Therefore, the force of friction is equal to 6.5 newtons. So again, you are able to logic through knowing what you know about free body diagrams. You're able to figure out 6.5 newtons pretty quickly. This is what it looks like mathematically. So are we done? No, because we're still looking for mu. What is mu? Well, there's only one equation that has mu in it. Force of friction equals mu times force normal. We now know what mu is. I'm sorry. We are looking for mu. We know what the force of friction is. Now we need to figure out the force normal. So now that we have the force of friction, to find mu, we're going to have to find out what the normal force is. So, since the box is not accelerating in the up-down direction, the normal force must be equal to the force of gravity. What's the force of gravity? mg. We have the mass of the box, 2.6 kilograms, multiplied by acceleration due to gravity, 9.81 meters per second every second, or meters per second squared. When you multiply those together, you get 25.5. Kilograms times meters per second squared are the units for the Newton. So we have 25.5 newtons. So, putting it together, force of friction, 6.5 newtons. Force normal, 25.5 newtons. And we're going to take this equation and solve it for mu. So how do we get mu by itself? We divide both sides by Fn. If I divide this side by the normal force, then I've got to divide that side by the normal force. And I have mu equals force of friction divided by force normal. 6.5 divided by 25.5 newtons. So, 0.255. Notice that this is greater than 0, less than 1. Am I missing anything? Or is this the final answer? What about units? Well, I have 6.5 newtons divided by 25.5 newtons. The units cancel out. Mu, coefficient of friction, is a unitless quantity. It's only a number. And that concludes our exploration of friction forces and the coefficient of friction. What I'd like you to do now is to look up typical coefficients of friction. For instance, what would be the coefficient of friction between ice and wood? Or wood and metal? Or wood and wood? It shouldn't be too hard for you to find out what typical coefficients of friction would be between two different surfaces. So look it up, look for ones that you would experience in your everyday life. Thank you very much for watching, and peace out. Well, before I go completely out, what exactly do you want to be looking for? I would say look up at least 5 different coefficients of friction between surfaces that, again, you might be coming in contact with in your everyday life.